2012, Paper 1, Non Calc. Question 1, Part A. Write down the size of angle X. Angle X is equal to 64 degrees because opposite angles are equal to each other. Work out the size of angle Y. This angle here is equal to angle X because we have alternate angles, so Y is equal to 180 minus 64, which is equal to 116 degrees. 1 Part C. Choose the correct word from the list to complete the sentence. Angle X and angle Z are corresponding. In a game, players spin 2 wheels. The wheels are fair. The numbers are added to get a score, and the wheels currently show a score of 4 plus 8 equals 12. We've been told we can use the grid below to help us answer the questions on the next page. This grid is an example of a sample space. It shows every possible outcome of this particular experiment. For example, if we have a score of 1 on wheel 1 and a score of 1 on wheel 2, that's a score of 2 overall. 3, 4, 5, 6, etc. So we can see a fully completed grid. These annotations will be useful for 2 Part A and 2 Part B. Part A. What is the most likely score? If we flick back, the most likely score is 9, which comes up 8 times more often than any other score, giving it a probability of occurring of 8 out of 64. 2 Part B. Work out the probability of winning a prize. From the annotations on the previous page, we need to see how many times do these numbers 2, 3, 15 and 16 come up. And overall, we can count that they come up 6 times out of 64, which means that the probability of winning a prize is 6 out of 64, or to simplify it, 3 out of 32. Question 3. There are 36 men in a running club. The pie chart shows information about their favourite races. So, we can deduce a few things from this. We know that a quarter of the men in the running club prefer the half marathon, and as there are 36 men in the running club, this means that 9 men prefer the half marathon. From looking at the angles, we can see that a third of the men, because 120 is 1/3 of 360, prefer the 10k. So 1/3 of 36 is 12, which means that 12 men prefer the 10k. We can see that 80 degrees represents the marathon. Now, 80 over 360 simplifies down to 2/9, which means that 2/9 of the men prefer the marathon. 2/9 of 36, well, 1/9 of 36 is equal to 4, so 2/9 is equal to 8 people, so 8 men prefer the marathon. Now, if we add those numbers up, 9 plus 12 plus 8 comes to a total of 29, which means that there must be 36 minus 29, which is 7 people who prefer the 5 kilometres. We can use this information to help us with the actual question that comes up in the next part. There are 20 women in the running club. Here is information about their favourite races. The same proportion of women prefer the half marathon as men. Now, we knew a quarter of the men preferred the half marathon, so this means a quarter of the women prefer the half marathon. So we need a 90-degree sector to represent the half marathon. The same number of women prefer 5-kilometre races as men. Now, we worked out that there were 7 men who preferred the 5 kilometre race. So that means we've got 7 women out of a total of 20, and we multiply that by 360 to work out the angle of the sector. Now, a simple way of doing that is to cancel down the 20 and the 360, so that would simplify to 1 and 18, giving us a total angle of 126 degrees for that sector. Finally, equal numbers of women prefer 10k races and the marathon. So if we subtract 90 and 126 from 360, we get a total of 144 degrees, which represents the 10k race and the marathon, which means that both of these are 72 degrees each on our pie chart. Question 4, Part A. Describe fully the single transformation that maps shape A to shape B. Now we can see that shape A, when it's transformed into shape B, it doesn't change size and it doesn't change direction, which means that the transformation that's most likely to have taken place is a translation. Now we can see if we pick this point over here, it's moved 1, 2, 3, 4, 5, 6, 7 places along, and then it's moved 1, 2 places down to get to that point there. To ensure that we get both marks, we need to say that a translation has taken place with vector 7 minus 2, i.e. shape A has moved 7 places along and 2 places down. For part B, draw the reflection of shape B in the line y equals minus 1. First of all, draw in your mirror line y equals minus 1. And then draw in the reflection of shape B. Shape B is 2 units away from the mirror line, so we need to make sure we are 2 units away on the other side when we start drawing in the reflection. Five. Solve 9x minus 3 equals 4x plus 17. I'm going to subtract 4x from both sides of this equation first of all, giving us 5x minus 3 equals 17. I'm then going to add 3 to both sides of the equation, giving us 5x equals 20. And then to finish off, we're going to divide by 5, giving us x equals 4 as our final answer. Question 6, Part A. Factorise 7x minus 21. Now, the only common factor in the terms 7x and 21 is 7, so if we take that outside the brackets, that leaves inside our brackets x minus 3. And always check back in your head to see that you've factorised correctly. 7 multiplied by x is 7x, 7 multiplied by negative 3 is negative 21. 6 Part B, multiply out or expand 4 bracket y plus 9. So we know that 4 multiplied by y is 4y, 4 multiplied by 9 is 36, and it's a positive 36. Question 7, expand and simplify 5 bracket x minus 3 take away 2 bracket x take away 1. The thing to be really careful about here is the fact that there is a minus multiplied by a minus in the second bracket here. So expanding the first bracket is simple, 5x take away 15. Then dealing with the second bracket, we've got negative 2 multiplied by x, which is negative 2x, and then negative 2 multiplied by negative 1, which is a plus 2. Then, when we collect like terms, we've got 5x take away 2x, which gives us 3x, and we've got negative 15 plus 2, which gives us negative 13. So the final answer. Question 8. The steepness of a railway track is shown by signs like this. On the left of the sign, the track is level. On the right of the sign, the track rises 1 metre for every 200 metres travelled horizontally. Essentially, what we're saying here is that on the right-hand side, the gradient, as indicated by this diagram here, is equal to 1 over 200. Question 8, Part A. Which side of the sign shows the steeper track? Show clearly how you decide. You may use a diagram to explain your answer. So on the left-hand side, the steepness of the track is such that for every 150 we go along, we go up 1. That means that the left-hand side has a gradient which is equal to 1 over 150. On the right-hand side, the track is such that for every 120 we go along, we go up 1, which means that the gradient is equal to 1 over 120. Now, comparing these two gradients, a gradient of 1 over 150 is less than a gradient of 1 over 120. You're dividing by a bigger number, so the answer is going to be smaller, which means that the 1 in 120 side of the track is steeper. 8, Part B. The steepness can also be measured as a percentage. For example, 1 in 200 would be 1 over 200 multiplied by 100 equals 0.5%. The steepest railway line in Britain has a percentage of 2.5%. Fill in this sign to show a steepness of 2.5%. So this means that 1 over our steepness, which we'll call x there, multiplied by 100 equals 2.5%. Let's divide both sides of this by 100, which gives us 1 over x is equal to 0.025. Now, 0.025 as a fraction is equal to 25 over 1000, which, if we simplify that down, is 1/40th. So the answer is 1 in 40. Question 9. The length of this rectangular tile is 6 times the width. 2 tiles are put together to make this shape. So we can annotate the diagram with some information. This is 6x, this is 6x, x, 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 and x. The perimeter of the new shape is 24 centimetres. Work out the width of one tile, i.e. find the value of x. So we're going to set up an equation to do this. We know that if we add together the total of the distances around the shape, we've got 6x plus 6x plus 2x plus 2x, which is 4x, and that must equal 24, which gives us 16x equals 24. Divide both sides by 4 gives us 4x equals 6. X is equal to 6 over 4, or 1.5 centimetres. Question 10. On the grid, draw lines to show the region satisfied by the 3 inequalities given below. Now, the first inequality is x is less than or equal to 4. What we're going to do is draw the line x equals 4 onto our diagram. And here it is, x equals 4. Notice the inequality was a less than or equal to inequality, so we need to make sure we use a solid line and not a broken line. Now, we want x to be less than or equal to 4, which means we don't want any of the region where x is greater than 4, so I'm going to shade out all of the region to the right-hand side of this line. Our next inequality was y is less than or equal to x, so we're going to start off by drawing the line y equals x. So here's the line y equals x. Now we want y to be less than or equal to x, so I'm going to shade out the region that we don't want, which is everything above the line here, where y is greater than x. Now our third inequality was x plus y is greater than or equal to 4. So what I'm going to do is start off by plotting the line x plus y equals 4 by putting on some coordinates that would fit that equation. Now, two very simple examples are 0, 4 and 4, 0. So here's the line x plus y equals 4. Now we want x plus y to be greater than or equal to 4, so if we pick any point, for example the point 3, 2, we know that 3 plus 2 is equal to 5, which is greater than 4, so we want that point to be included, which means we want everything above this line or to the right of this line, which means we don't want the region down here. Final task is to make sure we label the region we want clearly with a letter R, which is done like so. Question 11, part A. ABC is a right angle triangle. Work out the size of angle Y. It's useful to notice that triangle BDC is an isosceles triangle. We're going to start off by working out the size of angle ADB, this angle here. Now that's equal to 180 minus 50 minus 90, which gives us a value of 40 degrees. So that's 40 degrees. This then helps us work out the size of this angle here, angle BDC, which is equal to 180 minus 40, which is equal to 140 degrees. Now this tells us that 2y must therefore equal 40 degrees, so y has got to equal 20 degrees. Question 11, part B. A circle is drawn around ABC. Give a reason why BC is a diameter of the circle. Now, the key thing here to notice is that this angle here, angle BAC, is equal to 90 degrees. So we have an angle at the circumference of 90 degrees, which must be subtended from a diameter, i.e. BC has to be a diameter. So if we write that down, angle BAC equals 90 degrees, i.e. the angle in a semicircle is 90 degrees. Therefore, BC is a diameter. Question 12. PQR, triangle PQR, is an enlargement of triangle ABC. Work out the scale factor of the enlargement. So the scale factor is taking us from 6 centimetres through to 15 centimetres. So to work out the scale factor of the enlargement, we need to do 15 divided by 6, or 15 over 6, which simplifies down to 5 over 2, so that's the answer, 5 over 2 or 2.5. 12, part B, write down the size of angle P. In an enlargement, the angles remain the same as the shapes are similar, which means that angle P is also equal to 60 degrees. Part C, work out the length of AB. Now, this time we're going from the larger shape down to the smaller shape, so we know that AB is equal to 20 divided by the scale factor of 5 over 2. So we can do this as a fraction calculation, 20 multiplied by 2 over 5, which is 40 over 5, or 8 centimetres. Question 13. Cucumbers are grown in a greenhouse or in a garden. The box plots show data about their lengths in centimetres. 13, part A. Write down the median length of the cucumbers grown in the garden. So if we look at the garden, the median is represented by this line here, which, if we look at the scale very carefully, is 27 centimetres. 13, part B. Give 2 comparisons between the lengths of cucumbers grown in the greenhouse and cucumbers grown in the garden. Now, our first comparison is going to compare the medians. Now we can see that the median for the greenhouse is slightly larger than the median for the garden, indicating that on average the cucumbers grown in the greenhouse were slightly larger on average. Now our second comparison is going to be related to the interquartile range for each sample. Now the garden cucumbers, or the garden grown cucumbers, have an interquartile range that stretches from here to here. So their interquartile range is equal to 35 minus 20, i.e. 15. The greenhouse grown cucumbers have an interquartile range that stretches from here to here, i.e. their interquartile range is equal to 32 minus 21, which is an interquartile range of 11. Now this means that the interquartile range for the garden cucumbers is larger than the interquartile range for the greenhouse cucumbers, which means that there is more spread or greater variation in the lengths of cucumbers grown in the garden compared to those grown in the greenhouse. Question 14, part A, factorise x squared minus 9. This is a difference of two squares, so it will factorise into a pair of double brackets x minus 3, x plus 3. 14, part B, hence, simplify fully this algebraic fraction. Notice that x squared minus 9, we were asked to factorise it in part A, so we can use our answer for part B as well. Now, what we're going to do first of all, however, is we're going to factorise 2x squared minus 5x minus 3. I'm going to do this using the slightly longer method for those of you who prefer to use that. I'm going to multiply the 2 by the minus 3, which gives us a value of minus 6. We now need to find two numbers that multiply together to give us minus 6, and which also add together to give us this value in the centre here, minus 5. Now, there's only one combination of numbers that will do that, and it is negative 6 add positive 1, negative 6 multiplied by positive 1. We use these two numbers to then split the middle term, so we rewrite our 2x squared minus 5x take 3 as 2x squared minus 6x plus 1x, or plus x. We then factorise the first two terms completely, so we take out of the brackets 2x x minus 3. We're going to need this x minus 3 in this second part here, and we're going to need to ensure that we have a plus 1 in front of that second bracket. This then gives us our full factorisation of x minus 3 and 2x plus 1. This then means that our algebraic fraction can be written as x minus 3, x plus 3 in the numerator, i.e. on top, over a denominator of x minus 3, 2x plus 1. We can then cancel down the x minus 3's, leaving us with an answer of x plus 3 over 2x plus 1, which does not simplify any further. Question 15. The area of a trapezium is given by this formula here. For a trapezium, A equals 5 cm, B equals 8 cm, and H equals 6 cm. All measurements are given to the nearest centimetre. Work out the minimum possible area. So we need to know what the lower bounds are for each of these values. Now the lower bound for A is 4.5 centimetres, the lower bound for B is 7.5 centimetres, and the lower bound for H is 5.5 centimetres. So to work out the minimum possible area, we're going to need to substitute these three lower bounds into this formula over here. So the simplest way to do that would be to add together our A plus B, which is 4.5 plus 7.5, which gives us a value of 12. We then want to make sure we have a half of this, a half of A plus B, which is equal to 6, and our final step is to multiply this by H, which means we need to do 6 multiplied by 5.5. Now 6 multiplied by 5 is 30, 6 multiplied by 0.5 is 3, so the final answer is 33 centimetres squared. 15 part B, rearrange the formula to make H the subject. So the first clear thing that we need to make sure we do is to multiply both sides by 2, so we get 2A equals A plus B multiplied by H. We're then going to divide both sides by A plus B in its bracket, which gives us 2A over A plus B equals H, and then we're done. H is equal to 2A divided by brackets A plus B. Question 16. The manager of a company wants to survey his employees. He decides to sample 20% of them, stratified by the type of job they do. This table shows the number of employees. Now, we know that there are 40 employees in total, so in the sample, we need to make sure there are 20% of 40. Now, 10% of 40 is equal to 4, so 20% of 40 is equal to 8. So we need to make sure our final total comes to a value of 8. Now what we can do very simply is to work out the value of 20% of each of these groups. So if we start with the office staff, we can work out that 10% of 12 is equal to 1.2, so 20% is equal to 2.4. For the drivers, we can work out that 10% of 24 is equal to 2.4, so 20% is equal to 4.8, or we could simply have doubled our 2.4 from here. And then finally, with our mechanics, 10% of 4 is equal to 0.4, so 20% is equal to 0.8. There are other ways of working out these numbers as well. So in theory, we need 2.4 office staff, 4.8 drivers, and 0.8 mechanics. Now obviously we need to round these up to sensible values, so what we're going to do is take 2 of the office staff, 5 of the drivers, and 1 of the mechanics, rounding up to the nearest whole number, and if we check, 2 plus 5 plus 1 comes to a total of 8. Question 17. Write root 12 plus root 75 in the form a root 3 where a is an integer. Now what this question is asking us to do is to simplify each of these thirds in turn. So starting off with root 12, we can rewrite that as root 4 multiplied by root 3, which is 2 root 3. Root 75 we can write as root 25 multiplied by root 3, which is 5 root 3. If we then add together 2 root 3 and 5 root 3, that then gives us a total of 7 root 3. Question 18. Write these numbers in order of size, starting with the smallest. You must show your working. So we're going to start off with 27 to the power of a third, which is the cube root of 27, which is 3. Then 27 to the power of 2 thirds is very simply 3 squared, which is 9. So the answer to the first part is 9. Then 64 to the power of 1 third is very simply the cube root of 64, which is equal to 4. So 64 to the power of a third is 4. Now the last part is 4 to the power of 3 over 2, so we're going to start off by working out 4 to the power of a half, which is the square root of 4, which is 2, and then we simply have to do 2 cubed, which is 8. So the answer to the third part is 8. So putting these in order, starting with the smallest value is of course 64 to the power of a third, the middle value is 4 to the power of 3 over 2, and the largest value is 27 to the power of 2 thirds. Question 19. ABCD is a triangular base pyramid. The base BCD is a right angled triangle. A is directly above B. BC equals BD, so this side BD is also equal to x, and AB equals 2 times BC, which means the height of this pyramid is 2x, and the volume of the pyramid is 72 centimetres cubed, and you've also conveniently been given the formula for the volume of a pyramid, a third multiplied by the base area multiplied by the height. So we have to now calculate the length of BC, which has been labelled x in the diagram. So we're going to use all of the information that we've got in order to set up an equation and then find x. So we know that 1/3 multiplied by the base area multiplied by the height equals the total volume of the pyramid, which is 72. Now, the base area of this pyramid is the area of this right angle triangle, which if we draw it out, there's D, there's our right angle, there's B, there's C. This side BC is x, this side BD is x, so the base area is very simply x multiplied by x divided by 2, which is a half of x squared. So in our formula here, we can do 1/3 multiplied by half x squared multiplied by the height, which is equal to 2x, and all of this must come to a total of 72. Now we're going to simplify the left-hand side of this slightly. We have 1/3 multiplied by half multiplied by 2, so 1/2 and the 2 will cancel out, leaving us with 1/3. We have an x squared and an x, which will simplify to make x cubed, and this is equal to 72. Now we're going to multiply both sides of this by 3, giving us x cubed equals 216, and then to solve this we need to work out what the cube root of 216 is equal to, which of course is 6. So the answer is x is 6 centimetres. Question 20. The diagram shows a sketch of the graph of y equals x squared plus ax plus b. The graph crosses the x-axis at 2, 0 and at 4, 0. Work out the value of b, which we should note is the same as the y-intercept in this case. You must show your working. Now, if the graph crosses the x-axis at these 2 points, 2, 0 and 4, 0, it must have roots at 2 and 4, which means that its equation must be of the form x minus 2, x minus 4, as the factorised version of our quadratic equation gives us roots of x equals 2 and x equals 4, i.e. the x-intercepts. If we then expand our pair of brackets, we get x squared minus 6x plus 8, which, if we compare this with y equals x squared plus ax plus b, this very simply tells us that b has got to equal 8.